You're listening to AI Podcast. I'm David Chen, and today we're unpacking a paper called ToolLLM. The quick takeaway is this. Open models can be trained to use real web APIs at scale, plan multi-step tool use, and recover when a plan goes off track. The authors built a large dataset of real API interactions, added a search and backtrack planning method, and created an automatic evaluator. Their fine-tuned model ends up close to ChatGPT on tool use tasks, while GPT-4 still leads overall.
I'm Maya Patel. Thanks, David. So if someone's hearing this on their commute, the headline is that open models can handle real tools, not just toy demos, right?
That's right. And a quick word on authors. This work is led by Yujia Qin, with senior authors Zhiyuan Liu and Maosong Sun at Tsinghua University, and collaborators from Yale and industry partners. The paper first appeared on arXiv in 2023 and was later presented as a spotlight at ICLR 2024.
Okay, set the stage for me. What problem are they actually trying to solve?
Think about booking a trip. A model has to pick the right flight API, fill parameters exactly, handle errors, maybe call a hotel API, and then check local events. Open models often stumble on that chain. Earlier datasets were small, synthetic, or didn't execute real calls, and evaluation was messy because there isn't always a single correct path. The gap they tackle is realistic scale and reliable evaluation for tool use.
Makes sense. So how do they approach it without getting lost in a sea of APIs?
Two big pieces. First, they build ToolBench, a training corpus based on real services, more than 16,000 APIs collected from Rapid API, so the model learns from live endpoints with real responses. Second, they introduce a planning strategy that explores one path, and if it hits a dead end, it can backtrack and try alternatives. It's like troubleshooting your Wi-Fi. You don't just keep repeating the same step. You try another fix.
And to keep the search focused, I'm guessing they don't show the model every tool at once.
Exactly. They add a neural retriever that ranks a short list of candidate APIs for each request. That way, the model chooses among relevant tools rather than the entire marketplace. And because they actually execute calls during training and evaluation, the system learns to react to real-world errors and quirks.
Evaluation is always tricky here. How do they decide if a tool using conversation was good?
They propose an automatic judge called ToolEval. It checks whether the model finishes the task within a step budget, and when comparing two full solutions, it picks the better one based on usefulness, factuality, reasoning quality, and cost. They also compared this judge with human ratings and found strong agreement, good enough to run large experiments without hand-labeling everything.
All right, so what did they test and how did it turn out?
They evaluate single-tool tasks, multi-tool tasks within a domain, and then multi-tool tasks that cross domains. They compare common prompting baselines like React against their search and backtrack method, and they test a range of models, from open-source Instruct models to ChatGPT and GPT-4. The backtracking approach improved success rates as tasks got harder. Their fine-tuned open model, ToolLLM, beat some strong older baselines and approached ChatGPT on this benchmark, while GPT-4 remained best overall. There's a nice twist, too. When they used the retriever to select tools instead of an oracle list, performance sometimes improved because the retriever surfaced a better API than the obvious choice.
That's interesting. Discovery matters as much as execution. What about new tools the model hasn't seen?
They tested out of distribution on a benchmark called API Bench. ToolLLM read the documentation and performed competitively with specialized systems built for that setting, which suggests the approach transfers beyond the exact tools used for training.
Could you give a concrete feel for the planning behavior?
Picture a Lisbon weekend plan. The system retrieves a flights API, a hotels API, and a city events API. It tries the Flights API, gets an error about date format, adjusts or switches to an alternate Flights API from the shortlist, then moves on to lodging and events. If one endpoint goes down, it backs up and tries another path. It doesn't freeze at the first bump.
Nice. Now let's talk trade-offs. What should listeners keep in mind?
First, the automatic judge is an LLM acting as a referee. It's convenient and correlates well with humans, but different prompts or model versions could shift scores. Second, the dataset relies heavily on synthetic task generation guided by a strong model, which may introduce bias. Third, real APIs change over time. Endpoints and rate limits move, so exact replication can be tricky. And finally, exploring multiple branches improves reliability, but also adds cost and latency.
And scope-wise, most tools here are RESTful with decent docs. Enterprise systems can be stateful, authenticated, or use other interfaces like gRPC or GraphQL.
Exactly. This work is a strong foundation for REST APIs with text documentation. Extending to stateful or long-running workflows and different interfaces is a natural next step.
So what's the bottom line and where do we go from here?
The contribution is a practical recipe. Build a large corpus of real API interactions, teach the model to search and backtrack through tool choices, and use a scalable judge to measure progress. It moves open models closer to practical tool use. Next steps include more robust and transparent evaluation with larger human audits, richer tool ecosystems beyond REST, and planning that bakes in permissions, costs, and rate limits so agents behave responsibly in the wild.
I'd add measuring real outcomes, like time saved or support tickets reduced, not just pass rates. That's what end users care about.
Well said. If you're building agents today, ideas from this paper are immediately usable. Retrieval over tools, plan and backtrack reasoning, and disciplined evaluation. Just keep the limitations in view as you deploy.
Thanks, David, and thanks to everyone listening. This has been AI Podcast. If you found this helpful, share it with a teammate, and we'll see you next time.